In HTS, each beam uses typically 1/4 of the available satellite bandwidth. Adjacent beams uses different frequency or polarization. Satellites operating in beam hopping are using the entire bandwidth in all beams. Adjacent beams are illuminated at different times and avoid interference. The beam hops between different areas per momentary demand. Beam hopping advantages. Capacity increase. Due to lower interference between beams, an efficient amplifier's operation is achieved by operating closer to saturation with lower OBO. Flexibility. Bring the bandwidth where it's needed and when it's needed. Reduced cost is achieved by reducing the number of TWTAs aboard the satellite and hence reducing the payload power consumption and cost. The following use case scenario demonstrates the beam hopping advantages with its dynamic capacity allocation over time. Flexibility. It's now 8 p.m. EDT over the U.S. East Coast region, which is the peak demand time for services. While in the West Coast region, 5 p.m. PDT, traffic demand is much lower. Therefore, the beam hopping satellite illuminates the East Coast region with longer beam dwell time to meet this demand. Well, time flies, and it's now 11 p.m. EDT over the East Coast region, and capacity demand dropped, while on the West Coast, it's now 8 p.m. PDT, which is the peak hour of capacity demand. The beam hopping satellite changes its illumination plan, providing longer beam dwell time to the West Coast region. This reduces the unmet capacity and increases the overall delivered capacity. SatixFy SX3000 ASIC SDR satellite modem is the first to support beam hopping in the market. VSAT terminals based on the SX3000 are readily available. SatixFy provides beam hopping testbed to its customers. SatixFy revolutionized the satellite market with its innovative solutions and making beam hopping happen.